Hey guys, talk about even multiplicity and odd multiplicity. And what this concerns is the factored form of a function. When we're trying to find the zeros and we factor our function down. Here's an example. We have a quadratic, okay, a trinomial, degree of 2, leading coefficient is 1. Whenever I factor this is the form that I get. If you'll notice, here I have a variable, and that can be any variable that they place into the problem. A, B, C, up to X. Uh, if you watch any video, sometimes you'll hear people say Z instead of Z, or Z. C is used in lieu of a number, a constant. Okay, C is the constant. So that's what the number represents as C. And how this works is that if you have the factored form of a function, and it is to a power. And all of them are to a power because I can put anything to the first power. Where that fraction or that exponent is greater than or equal to 1, and there is not another form of that to a higher power. Meaning what this means is that if I have x plus 1 squared and x plus 1 to the third, I need to combine those. I'm not looking at two separate things because it all deals with the number 1. Okay? So as long as I don't have that and I combine them, if k is odd, so if my exponent is odd, then the graph crosses the x-axis. It intersects across. Okay? It goes through. So if k is odd, and remember the number 1 is odd, if k is even, then the graph is tangent to the x-axis. And it deals with the number that is in that factored form, C. And we already know this, is that what we're looking at is the intersection when we find the zeros. This one here, it does touch, but the tangent line, here's an example of a tangent line. A tangent line is a line that is drawn that will intersect at one point. It just touches it of a graph. So when we're talking about a tangent line, it means that line goes all the way down, for this case the x-axis, and touches it in just one point. It does not go through, it just touches it. So if k is odd, then you have that actual intersection, the crossing at the x-axis. If k is even, then the graph is tangent. It just touches it and goes back. So let's look at an example. State the multiplicity of each zero and its graphical appearance. Most of your problems that you'll have are already factored. So what I do is I look at this and I say, okay, well, I have two factors here. One is to the second power and one is to the first power. And that's how that can be viewed. X plus 3 squared is simply x plus 3 times x plus 3. So I look at that. So whenever x equals a negative 3, there's a multiplicity of 2. Therefore, the graph is tangent at 2 comma 0. And here, x equals 1, it has a multiplicity of 1, and that means that the graph intersects. It goes through, it crosses at 1 comma 0. So let's look at that as a graph. Here are my points. Whenever x was a negative 3, there was a multiplicity of 2 that is even. Therefore, the graph is tangent. The graph goes along, it comes up to where x is a negative 3, and it just touches it and goes back. At x equals 1, there was a multiplicity of 1, meaning that the graph will cross the x-axis and intersect it there. 1 comma 0. Your multiplicity, we can call it test, helps us because we just learned about in behavior, right? We learned about in behavior, and all of this we're getting from uh, form of our polynomial function, whether we're looking at the first term or the factored form of the polynomial. But with looking at our first term, our leading term, we understood the in behaviors, and just draw a representation. We had something like this. And then what we had there is a squiggly line saying we don't know what's in the middle, we just know the in behaviors. This right here, multiplicity, helps us to be able to understand better what is going on in the middle, what is occurring in the middle. All right, so let's look at some other examples. All right, so what I'd like you to do, pause the video, determine the multiplicity, and then what will the intersection be? Will it cross the x-axis or be tangent to the x-axis? And you can go ahead and do both of these graphs, and then what I'll do is we'll work it, and then I will pull up a graph of each function. Okay, so let's look at our problem. First off, what does k equal? K equals 3. Therefore, it's odd. So what do I know that it's going to do? It's going to cross the x-axis. And just another way to be able to look at it so that you see is that this is what this actually is. My problem here is that x is actually squared. It's not x minus 9. So what do I need to do is that I need to actually find out what this x equal. This is my c. C equals a negative 3 and 3. Therefore, where I know that it crosses at is at the points negative 3, 0 and 3, 0. Again, what this helps me do is I can look at in behavior by looking at the leading term, but this helps me understand what is going on in the middle there. So let's pull up a graph and take a look, and this is my graph. Notice negative 3, 0, 3, 0, and they both cross. And then this is the actual graph. Look at that. It goes on and on and on all the way down to a negative 729. But for what we're worried about, what we're looking at is what's the action going on there at the x-axis. All right, so that was the first example. Let's look at the second example. All right, so k equals 2. 2 is even. Therefore, tangent to the x-axis. Again, what this shows is x squared minus 4 times x squared minus 4. But x is squared. It's not in the form that they give me. It's not in the form x minus c. And plus or minus is irrelevant in this. I'm sorry, I should have already talked to you about that. Plus or minus is irrelevant in there because this, I could have whatever numeric value for c. What this is meaning is so that you're not ending up excuse me, so that you're not ending up with an imaginary non-real number. But it is irrelevant, plus or minus what they write in there. So what this turns into is x squared minus 4 equals 0. So I know that x squared equals 4. You see that? If it was x squared plus 4, I would end up with x squared equals a negative 4, and I would end up with a non-real number. And then what we have is that x equals plus or minus 2. So what does c equal? C equals a negative 2, 2. And I know that my points will be these. And again, this tells me some of what's going on in that middle area around there. And if I look at the graph, here's my graph. It is tangent at a negative 2, and it is tangent at 2. It just comes down and touches and goes back up. Comes down and touches and goes back up. Only touching it at that one particular spot. So if I just went over just a tad, and it'll only go to the hundreds place, see, come along, and then it goes right to 2. It's only touching at one spot. Alright, guys, that is even and odd multiplicity. You need to make sure that you do have memorized that whenever k is odd, k is your exponent, it crosses the x-axis. And whenever k is even, tangent to the x-axis. And I'll write that in there for you too. Just touches. Alright, continue to watch the publisher's videos, structure and critically think about your homework, and good luck on the rest of your homework.